topic is statistics and sampling. The essential question is, how do you distinguish between a population and a sample? And what composes a good sample? The word composes means makes up. So what makes up a good sample? So we'll start off with the definition of statistics. And statistics is the study of data. And the three functions of statistics is to collect data and info via experiments, surveys, interviews, tests, etc. So that's one of the functions of the study of data, is to collect data. Which is info. Through, or via means through, experiments, surveys, interviews, tests, etc. Okay. Another function of statistics is to organize the data in tables, graphs, and charts. And the third function of statistics, which is the study of data, is to analyze and interpret the data to make conclusions. Okay, so I want to repeat this. Statistics is the study of data, and the three functions of statistics is to collect the data, and ways that they can collect data is through experiments, surveys, interviews, and tests. And after that, they'd organize this information, the data that they collected, into tables, graphs, and charts. And the reason they organize it like that is so that they can analyze and interpret the data to make conclusions. So the point is so that people can understand what the data really means in their relation to its context. So that's the whole point of statistics, so that they can understand what the data means. And from there, they can make decisions based on that data. All right. The definition of the next word is the entire group of people, animals, or things that's being studied. So it's the entire group of these things that are being studied. That's called a population. Okay? It's the entire group that they're interested in gathering data on, the entire group. And the next definition is of a sample. So when a population is too large to collect data on, you can collect data on a sample. Sometimes it might be too expensive to gather data on an entire population because it might be really, really giant. So you just kind of collect a sample of that entire population. But you got to make sure that that sample is representative of the population. And what that means is it's got to represent that entire population. You don't want it to be all similar. You want to collect a variety of the things composing that population, okay? A sample is only part of the population. All right, for your summary, I want you to describe the difference between a sample and a population. What is the difference between a sample and a population? Since samples are only part of the population, they must be selected correctly in order for them to be valid and accurate. So remember, a sample, it's only part of that population you're interested in. And when you select the people or the things in your sample, you got to do it correctly so that your data is valid and accurate. So samples chosen to collect data on must be There's 3 criteria for a good sample, okay? First thing, it's got to be fair. Another word for fair is unbiased. If I said something was biased, that would mean it's unfair. But fair means unbiased. The second criteria for a good sample is samples must have enough participants or items in it. So if your sample is too small, then it's not going to be representative of the data. For example, if you're curious about surveying everyone in Moses Lake regarding their opinion on the building of a new boat launch, you wouldn't just sample like 5 people. That would not be a big enough sample of the entire population of Moses Lake, okay? And you'd want it to be fair to where you would pick people of all walks of life. You wouldn't just survey the people that like to go fishing. See how that would be biased? We want something to be fair, okay? Anyway, the third criteria for a good sample is the sample participants must be selected randomly. Okay? You have to have an equal chance of being selected for it to be random. So, since it says sample participants must be selected randomly, here's an example of something that would not be random. If for your sample you just surveyed just your friends. See how that's not random? It's not representative of the population. You want everyone in your sample to have an equal chance of being chosen. Okay, and they can't just all be your friends, because that wouldn't fit the 3 criteria of a good sample. All right, let's go ahead and have our first example. So a survey is made to see which TV programs are most popular in a large city. Which of the following places would get the most accurate survey results, and why? So for starters, we need to survey just a sample, because we don't want to poll or survey every single person in a large city. That would take forever, and that would also be very expensive. And plus, I don't know if you could reach every single person in a large city. So therefore, that is why you would have to collect a sample. Which of the following places would get the most accurate survey results, and why? So when you're pulling your sample, you want to make sure that the sample is fair, which means unbiased. The sample must have enough participants in it, and they've got to be selected randomly. It's got to fit those 3 criteria for it to be a good sample for this large city survey, okay? So a sporting event. Does that fit the 3 criteria? Well, when I think of people surveying people from a sporting event, they're probably more likely to prefer sports shows. Okay. People at a rock concert. Should I survey them to ask them about their TV programs that they would prefer? Well, when I think of people at a rock concert, I think they're more likely to prefer music shows. And this would probably also be a limited age group, because if they go to like a classic rock concert, typically those are an older age of people. If they go to maybe like a rap concert, that's also probably a different age group also, okay? So these people would be more likely to prefer music shows, and there could possibly be a limited age group. Okay, so you'll notice I'm just jotting down information for each of these 3 options, and then I'll select the best one that fits this 3 criteria for my sample. So mall, taking your sample from people at a mall. Well, a mall has all ages, and there's a diversity of people. Okay, so let's go back up here for that 3 criteria of a sample size. We want to be fair. Well, is this one fair right here? Is it unbiased? Well, it's not really fair because the people, if you survey people from a sporting event, they're more likely to prefer sports shows. So they'd probably say, yeah, we just like to watch ESPN or something like that, okay? Is people at a rock concert, is that fair and unbiased? Well, I don't really think so because these people at a rock concert are more likely to prefer music shows, and this could also be a limited age group, okay? There might not be a lot of teenagers at this, or there might not be very many old people at this. Let's see, fair and unbiased. Is a mall fair and unbiased? Yeah, there's all age groups there. Okay, the second criteria. Samples must have enough participants or items in it. Well, you can survey enough people at a sporting event, so that's a good thing. You can survey enough people at a rock concert, and you can survey enough people at a mall. So those all fit the criteria. Third one, sample participants must be selected randomly. They need to have an equally likely chance of being chosen. Well, you can accomplish all of those things within these 3 options. So it leaves us to which one is fair. The one that's the most fair is C. People at a mall fit this 3 criteria for a sample of the entire population, okay? The large city is the population. And we're going to pull our sample from the mall, okay? Okay, for your summary, I want you to write down in the space provided, what are the 3 criteria of a good sample? List them below. For the next examples, it wants you to determine if each of the below sample scenarios is unbiased, has enough participants, and is random. In other words, those are the 3 criteria for a sample to be a good sample. And if they don't meet this 3 criteria, you need to state why. So number 1 says, the health department wants to know the school lunch preferences of the K through 12, kindergarten through 12th grade students in the Moses Lake School District. So they survey 100 kindergartners. Let's go ahead and let's start by identifying our population. Which is the population that we're interested in learning more about? It'd be the K through 12, kindergarten through 12th grade students in the Moses Lake School District. That's our population. We're interested in gathering data about these people in this population, okay? So that's our population. The students, K through 12 students in the Moses Lake School District. I'm going to label that population. And they're saying for their sample, they want to survey 100 kindergartners. That's what they want as their sample. Is this a good sample? Well, let's see if it fits that criteria. Is it unbiased? Well, I think it's pretty biased. It's not a good sample. Okay, and the reason it's biased is because it's only hearing from the 100 kindergartners. It's only hearing from just this part of the population. It's not even asking about the 1st through 12th graders. It doesn't even ask them. So not a good sample because it's biased. It's unfair. Yeah, and it doesn't represent the population because it's got to have enough participants and represent the population. Population. Okay, the next question says, The principal is curious about the average amount of time Chief Moses Middle School students spend time texting each week. So she surveys every 10th student exiting the school. So what's the population? Who is the principal interested in collecting data about? It would be Chief Moses Middle School students. Okay. That right there is our population. Okay, now we got to see if her sample is good. So she surveys every 10th student exiting the school. So that would be her sample. Okay, does it fit the criteria? Is it unbiased? So is it fair? Every 10th student exiting the school? Yeah, it's totally unbiased. Check. Because every 10th student exiting the school could be a 6th grader, it could be a 7th grader, it could be an 8th grader. And is there going to be enough participants? Well, yeah, because if she's surveying every 10th one of them, that's going to be representative of the population. So, yeah, that's enough participants. And is it random? Yeah, it's random because it's every 10th student. It could be a 6th grader, 7th grader, 8th grader. Yeah, so it's random. They have a random chance of getting selected. Everyone's equally likely got a chance to get selected. So, yeah, this is a good sample, because it fits that 3 criteria. Okay? So see the differences between number 1 and number 2, how this was not a good sample of the population, and this one right here was a good sample of the population? So for your summary, I want you to write down, what does unbiased mean? Number 3 says, a PE teacher wants to know the average number of pull-ups the 7th graders at Chief Moses Middle School can do. So she tests the boys in first period. Okay, let's think of the population. She is interested in collecting data on the 7th grade students at Chief Moses Middle School. Okay, that's our population. And the teacher is going to collect a sample of that population. But remember, it's got to fit that 3 criteria. Well, first off, let's see. Just by looking at this, she's just going to test the boys in first period. That's who she thinks is going to be the sample. And is this a good sample? I can tell you right now, it's not a good sample. First off, it's biased. It's not fair, because it's only boys. When the population is interested in 7th graders at Chief Moses and she's just sampling the boys, that's biased. And also, she's only asking first period. So that's not random at all. Okay? Remember, it's got to have this 3 criteria. It's not random. Number 4. The leadership class wants to predict the winners of the school election, so they ask 250 students at random. So the population would be the students of the school. So let's see. They're going to ask 250 students at random. That would be their sample. Is that a good sample? Does it fit the 3 criteria? And if you forgot the 3 criteria, it's right here. So first off, is it fair? Is it unbiased? Yeah, it's unbiased because it's 250 students at random. 250 students at the school. So yeah, that's unbiased. That's good. Are there enough participants? There should be at 250 is a good number because we have about, I don't know, 800 kids or so. That's a good enough sample size. And are they random? Yeah, they're chosen at random. So yeah, this is a good sample. Number 5. The city council is curious about what percent of the town's residents enjoy going to the movies, so they ask every 10th person leaving the theater. So I want you to identify what the population is. Okay, underline or put a box around the population. And then I want you to tell me, is this a good sample or a bad sample? If it's a good sample, just write good sample and give me these check marks. If it's not a good sample, tell me why, like what we did in problem number 3. See how we said it wasn't a good sample? And I told you why? So number 5, you're on your own. And I also want you to write this summary out. Instead of surveying an entire population, why do we collect data on a sample of the population instead? Okay, so why might we just collect data on the sample instead of asking every single person? Why do you think we might do that? Write it out.